Hi everyone, my name is Caesar, and together with Liliana and Joshua, we are the LCJ Food Fanatics. We're students in COP 3530, Data Structures and Algorithms, and this is our Project 2B video demonstration. Here's our GitHub repo on the screen, where you have all the files necessary to execute this program. Here you have the README, the C, make list, the food data file, and all the coding files are in the SRC folder, sorry, where you can find all the coding files here, all 10 of them. Before we start, all the ASCII art in our program was created using this website, where you can type any word, any sentence, and put any font to create any ASCII art you want. It's an amazing website, and I highly recommend it. So, the problem we tackled is simple. What foods provide the greatest sources of each vitamin and nutrient? We wanted to make something useful that could help people understand which foods are rich in specific nutrients. And our motivation came from nutrition is often overlooked in modern diets. So our project aims to make that information more accessible and clear, as it's detailed here in our report. We extracted information from this website that provided a list of over 7,000 foods with the amount of different nutrients found in each one of them, as well as the micronutrient percentage in each one of them. Now, going to our program, we built our program in C++ using CMake and the STL. That includes the 10 files, sorry, plus the food data file. When you run it, boom, you're going to be greeted by this banner, which gives a program a fun and creative look to start off. So, our program reads data from a large CSV file that contains hundreds, or in this case, thousands of foods items and their nutrition values. We created a custom parser that can correctly handle commas and cite bullets. That is important because some food names, like for example, soup, comma, chicken noodle, would otherwise break the table. Once parsed, each food is stored as a food object in a vector, and each nutrient value is saved as a double. After loading the data, the program lists all the available nutrients in organized groups: general, fats, major minerals, and vitamins, as you can see here. We designed this section to be displayed in 4 columns, with continuous numbering. That way, users can easily scroll through and select which nutrients they want to analyze. We made sure the display order stays consistent so that when a user types the number, it matches exactly with the nutrient in the list. Now let's look at the main feature of the program. So let's pick a nutrient we wish to sort by. So let's choose 32, vitamin B6. And when you select the nutrient, the program sorts all the foods based on the amount of that nutrient. We implemented 2 sorting arguments, quicksort and hipsort. First, the program performs a quicksort, prints the top 5 foods high in that nutrient, and displays the elapsed time, as you can see here. Then repeats the process using hipsort for comparison, as you can see here. You can see both algorithms give the same results, but their runtimes can differ slightly depending on the data. We also added the ASCII art numbers, as you can see, to make the top 5 results stand out visually. Each food name and nutrient value is printed in a clean and readable format. Now, this part demonstrates how sorting algorithms behave on real-world data. The quicksort uses recursive partitioning, while the hipsort builds a max heap using our build heap and typify down functions. We use vectors and string from the STL to make everything dynamic and efficient. The time feature seen here in the main CPP uses chrono resolution clock to measure performance precisely. Finally, if you're done choosing your nutrients and you just say check another nutrient and you say no, you're left with this eat healthy message, just a small reminder that nutrition matters. It's a fun way to end the program while reinforcing our project's theme. Anyway, that's our Project 2 demonstration. Once again, we are LCJ Food Fanatics, and thank you for watching, and we hope you enjoyed our project.